The anatomy of Shadcn UI. I'm actually really excited about this blog post. Manupa has been sharing in part of the community for a long time, and the idea of deep diving into Shad UI and how it works is very, very exciting. And I've wanted to do this for a while, so without further ado, let's take a look. If you're roaming around in the JavaScript ecosystem this year, you might have come across this interesting UI library called Shadcn UI. Instead of being distributed as an NPM package, the Shad UI components are delivered through a CLI that puts the source code of the components into your project itself. For what it's worth, the CLI was a somewhat recent addition. As recently as a few months ago, the expected way to install these components was to copy-paste the code. The reason this is important is that you actually have all of this code in your code base, unlike other packages where if you install something like Bootstrap and you want to make changes, you can't. Or if you have something like MUI, you're limited by what variables and what properties they expose. With Shad UI, you have the code in your code base. It's yours. The CLI is just a convenient way to scaffold it and get it up. Shad mentions the reason for this on the website. He actually calls it copy-paste still. Why copy-paste and not package the dependency? The idea behind this is to give you ownership and control over the code, allowing you to decide how the components are built and styled. We start with some sensible defaults, and then you can customize the component to your needs. One of the drawbacks of packaging the components in an NPM package is that the style is coupled with the implementation. The design of your components should be separate from their implementation. I've been hammering this point home for so long. Let me find my best traffic over time video probably ever by comparing modern CSS solutions. This video has been a consistent 500 to 1,000 views a day for years now. And the reason why I think is this diagram I drew during it. This diagram breaks the CSS and style libraries into 3 chunks. I call them CSS++, behavior libraries, and style systems. When you think of a style library, what you're thinking of is probably a style system. Things like Bootstrap or Tailwind UI, where you have a bunch of existing ways a button looks that are built into the framework, and all of those looks and styles are inherited when you use that package. There's also behavior libraries, things like Radix or Headless UI. These behavior libraries define things like the behavior of a dropdown. These are important because of accessibility and browser standards. Getting things like a radio button's behavior right is difficult, and doing it correctly such that you're following expected accessibility standards is even harder. Then binding all of that to a framework like React, that's where hair starts to get pulled. And these libraries have solved so many of those problems, and a lot of work has went in to make it so your UI behaves how it should. The third category that I personally spend the most time thinking about is CSS++. These are things that are meant to extend CSS rather than provide CSS for you. The vast majority of classes that Tailwind gives you are one line of CSS. There's a little bit of opinions around how things should be sized relative to each other and their color palette. But Tailwind doesn't have a look. I see a lot of people say that every website looks the same because of Tailwind. No, absolutely not. Websites look the same because they're inspired by each other. Tailwind is just an easy way to build it. I promise you, I can make some very hideous websites with Tailwind that look nothing like the websites you're thinking of. Whereas something like Bootstrap absolutely makes all the websites look the same because they're using the same classes that have the same properties. Tailwind has as many classes as they have properties. They're fundamentally different in this way. There are also solutions that combine parts of these things, but I find that those solutions tend to take too much ownership and give up too much configuration in the process. But this is why Shad UI is such an interesting project, because Shad UI is touching on all of these things. It's using Tailwind, it's using Radix, and it is a style system, but it uses Tailwind, so it's not building its own alternative there. It's using Radix, so you have access to all the Radix primitives, and it's putting the code in your code base, so you don't have to deal with the opinions of the style system if you want to make changes to them. Back to the blog post. In essence, Shad UI is not just another component library, but a mechanism to declare a design system as code. My intention with this article is to explore the architecture and implementation of Shad UI to reveal how it's been designed to achieve the before-mentioned goals. If you haven't already tried it out, you should check out the docs. Totally agree. Really good docs. Really good job of showing you what these components are and how to use them. Any user interface can be broken down into a set of primitive reusable components and their compositions. We can identify any given UI component to be constituent of its own behavior set and visual presentation of a given style. First piece is behavior. Except from purely presentational UI components, think like a picture. UI components should be aware of user interactions that can be performed on them, and they should react accordingly. The foundations necessary for these behaviors are built into the native browser elements, and they're available for us to utilize. But in modern user interfaces, we need to present components that contain behaviors that cannot be satisfied by the native browser elements. Tabs, accordions, and date pickers. God, how is date picker not standardized yet? How the hell is date picker not standardized yet? And don't say it is. You're lying. You're wrong. Try supporting Firefox. Anyways, this warrants the need to build custom components that look and behave as we conceptualize. Building custom components is usually not difficult to implement at the surface level using modern UI frameworks. But most of the time, these implementations of custom components tend to overlook some very important aspects of the behavior of a UI component. This includes behaviors like focus and blur states, keyboard navigation, and adhering to all of these WAI ARIA design principles. This is what I was talking about before, where getting your interactions right might seem simple. Like you click a button, you run the on-click. But getting all of these things handled properly, even just blur states, not easy. And using tools that solve it for you is really, really useful. And as the author points out, even though behaviors are very important to enable accessibility in our user interfaces, getting them right and according to the W3C spec is a really hard task, and it could significantly slow down product development. This doesn't get enough credit as well. The effort it takes to get accessibility right isn't free, and I see a lot of accessibility advocates pretending it is. And this is so frustrating because both sides are just shadowboxing with an imaginary version of the other side. Anybody who's not doing a good job of implementing accessibility stuff doesn't just hate disabled people or people with needs for these tools, they just don't weigh those needs higher than the cost of implementing things correctly. Where on the other side, it's perceived as an attack whenever any website doesn't have every single ARIA spec managed and handled perfectly. I stand somewhere in the middle here, which is crazy because I'm a big accessibility advocate. I think this is a tooling problem, and we need better tools so that developers aren't slowed down when they follow these standards and specs. It shouldn't be easier to build things the wrong way. It should be easiest to build things the accessible way. And things like Radix, things like React ARIA, things like Headless UI are all working hard to fix that problem. And Shad UI is a really important piece of this increasingly complex puzzle. Given the fast-moving culture of modern software dev, it's difficult to factor in accessibility guidelines into custom component development for front-end teams. One approach a company could follow to mitigate this would be to develop a set of unstyled base components that already implement these behaviors and then use those across all projects. But each team should be able to extend and style these components to effortlessly fit the visual design of their project. These reusable components that are unstyled but encapsulate their behavior set are known as headless UI components. Often, these can be designed to expose an API surface to read and control the internal state. This concept is one of the major architectural elements of Shad UI. Yes, having a library of headless UI components that implement these behaviors correctly is so essential. So let's dive into the style section. The most tangible aspect of UI components is the visual presentation. All components have a default style based on the overall visual theme of the project. The visual elements of a component are twofold. First is the structural aspect of the component. Properties such as border radius, dimensions, spacing, font sizes, and font weights all contribute to this aspect. The other aspect is the visual style. Properties such as foreground and background colors, outlines, and borders contribute to this aspect. I actually like this breakdown a lot. I never thought of it this way, where you have the structural parts and the more visual parts. Good split. And I'll take this opportunity to emphasize the thing I want to emphasize a lot. Default font size for a thing meant to be read, like a blog post, should not be 12 point, it should not be 14, it should be 16 pixels minimum. I'm tired of having to command plus every post I go to just to read it. Anyways, based on user interactions and application state, a UI component can be in different states. The visual style of a component should reflect the current state of the component, and it should provide feedback to the users when they interact with it. Therefore, different variations of the same UI component should be created in order to accomplish this. These variations, often known as variants, are built by adjusting the structure and visual style of a component to communicate its state. I would go as far as to say this is actually something Tailwind isn't great at, the idea of variants. It doesn't handle well. They have their prefixes, which let you encode some level of this in the class names, but it's not deep enough. And I think stuff like class variance authority exists to showcase just how far this gap is. As people are already saying in chat, CVA saved Tailwind components. And I absolutely agree. If you're already familiar with CVA, it was created by Joe Bell, used to be a Vercel employee, and it was built to fix the problem of applying different styles with Tailwind. Here's an example of the button where it has a primary and a secondary set of classes that it applies, and then in different cases, you can change that and it will apply the right subset. Very, very good stuff, and basically necessary if you're trying to build a component library with Tailwind as one of the core pieces. During the development lifecycle of a software application, a design team captures the visual theme, components, and variants when developing high-fidelity mockups for the application. They also document different intended behaviors of components as well. This type of collective design documentation for a given software is usually known as the design system. Given a design system, the team's job is now to express that in code. They should capture the global variables of this visual theme, reusable components, and their variants. experience. The main benefit of this approach is that any change done in the future to the design system can be efficiently reflected in code. This would unlock a frictionless workflow between the design and development teams. All very important things. The relationship between design and dev is so important and underappreciated. One of the most impactful experiences I've had as an engineer was when I started working closely with a designer for the first time as I shifted more into front end. I should name drop her more. Her name was Iris. I worked with her at Twitch. She was incredible. Entirely changed my understanding of what designers were and what they did. I want to be very clear. She was not technical. She had no experience with code. So when we had issues with her designs that were code related, I assumed I would just be the engineer and say, sorry, we can't do that. Come up with a different design. But whenever I pushed back on things, she would ask really good questions. She didn't understand the weird behaviors of CSS, but she understood that something there was keeping her design from working. One in particular was the idea of overflows of backgrounds. The issue was that we had this card and it had this section that was colored. Forgive me for not doing a good job with that. You get the idea. We had this little section on top that had a background color applied to it. We had a button in here. So the annoying thing wasn't this, because you just put an overflow rule on the parent container, and now this gets its corners rounded properly and the background color is applied correctly. The issue was when you click this button, which is part of this container, this had a pop-out that had to go above like this. So I needed this to pop out over. But if you have an overflow rule on the greater container, in order to make sure the background color is applied correctly, this pop out would get cut off. It would get trimmed and you would only see it up to here, and the rest would just be eaten by the browser. Because the overflow rule was necessary to handle the background color, but that same overflow rule would keep your elements from popping out. I explained this to her quickly, and that yes, we can do crazy things with portals to yoink this out when you click it, but this was a very minimal code base, and I was the only engineer really working on the front end at the time, so we didn't have the time to set this all up, and this was well before the era of things like Popper being standard. I ended up being the one who pushed Popper at Twitch because of stuff like this, fun fact. But before we had all of that, I needed a way to keep this from happening. And what I told her was, I'm sorry, if you want to round the corners of this card, the background colors are not going to apply correctly because of this rule. She kept asking questions about it and how these CSS rules work. And I was admittedly a bit frustrated because I just told her why we can't do this, but she kept trying to understand. So I answered her questions because y'all know me. If you ask me an interesting question and you're actually trying to understand, I'm going to answer it. So I answered a bunch of her questions. She went and ran off, did her thing. I got back to work. She came back a little bit later with a different proposal now that she understood how this worked. She introduced the concept of layering with the elements in here, where this top part had no background color, but there was a second layer inside here that did, because her goal was very specifically to create a hierarchy of things within the card. So she figured out that the place where this button existed could be up here, not follow those rules, and still behave accordingly. And then the part with the color coding to show you what this was could be a little bit lower within a subcontainer that doesn't need to have these overflow rules, and ended up creating this type of depth with the cards we made for our report system that ended up looking better and fully complied with the constraints that I was under at the time. It was really powerful. The thing that shocked me was how willing she was as the designer to understand my constraints as the engineer, to work around them and make a good product. Because that was her job as a designer, is doing that for users too. She wasn't a super heavy Twitch viewer that understood the intricacies of every stream, but she talked to all of them. She talked to everyone she could to better understand what the user needed and what problems they had, because it was her job to turn those problems into a design that solves them. So when I presented her problems on the Eng side, she did the exact same thing. And I realized it was her role to be a bridge between the user and the engineers. And it entirely changed how I think about designers. And I realized so much of my job now is to align design with the actual implementation and the other engineers, specifically backend engineers who don't care about any of this stuff. I'm the in-between there. And it's my job to make sure everything comes together and my part as good as possible. And I ended up becoming one of the biggest design advocates at Twitch because I wanted to bridge this gap. So much so that when I left my final team at Twitch, half of the designers quit within the next 2 months. I cared so much about design that I inadvertently caused designers to keep their jobs because they thought that the huge gap between design and edge was being closed. But when I left, they didn't feel that way anymore. They left too. It's crazy how little respect design tends to get from Eng, especially at bigger companies. If y'all are watching this video, you're probably capable of bridging this gap. do it. You'll be amazed at how thoughtful, deep, and caring most designers are about all of this shit. Fun tangent, back to this blog post. Architecture overview. As we previously discussed, ShadUI is a mechanism by which design systems can be expressed in code. It enables a front-end team to take a design system and transfer it in a format that can be utilized in the development process. I think this architecture is worthy of our review. You're able to generalize the design of all ShadUI components into the following architecture. I love that as soon as I open Excalidraw, the author does too. Take a quick look at this guy. The ShadUI box is broken into these two pieces, the style layer and the structure and behavior layer. The style layer has multiple parts. It uses class variance authority and Tailwind to actually apply the styles. It uses CLSX and Tailwind merge to apply conflicting styles and make the utilities work when you add things externally. And it also uses some global style variables so you can configure how things look by setting a variable for things like primary color. There's also the headless component, which is the actual behavior of these things. And they use a bunch of things for this. Obviously, Radix UI is the core, but they also use TanStack's React table. They use React Hook Form, and I'm sure they use a lot of other things. I know that they just introduced something for the toast notifications that's really good, but they're leaning on external solutions that have good behaviors that are able to be styled well. It honestly feels like if I was building my own component library, the right choices I would have made for all these things. Let's break these layers down even further. The structure and behavior layer. This is the bottom part. In the structure behavior layer, the components are implemented in their headless representations. As we discussed in the prologue, this means their structural composition and core behaviors are encapsulated within it. Even the difficult considerations such as keyboard navigation and the area standard adherence are implemented by each of these components in this layer. So all of these pieces follow standards properly and work properly, so to speak. They just don't have any styles. They're using the default browser stuff. This includes things like the accordion, popover tabs, all of the crazy things Radix does for you. Native browser elements and Radix UI components are enough to satisfy most of the component requirements, but there are situations that warrant the usage of specialized headless UI libraries. One such situation is form handling. Forms. It's amazing we haven't made forms good yet. But as they call it here for this purpose, they're using the form component that is built on top of React Hook Form's headless form library management, which handles the form state and all the requirements there. ShadUI takes the primitives given by React Hook Form and wraps over them in a composable manner. I will say, someone who's not super fond of working with React Hook Form's an incredible library. It's more that forms suck than RHF sucks. So doing the hard parts and giving us components, it's a really nice win. That said, I am really excited for TanStack Form. Speaking of Tanner, let's talk about the table view, which uses the TanStack React table. The ShadUI table and data table components are both built on top of this library. This also includes, funny enough, the upload thing dashboard, specifically the file management. This is the TanStack table. Specifically, it's the ShadUI TanStack table, and it is the least pain we've had dealing with tables. It's far from perfect because tables suck, but it looks great, works great, and behaves as expected, which is non-trivial. Good stuff. They also have things like calendar views, datetime pickers, and date range pickers, and they're solving most of these using the React Day Picker package. Didn't know that was a thing. Very, very useful. And that's the base component, and that's the headless piece that they then implement styles on top of. Speaking of which, we should talk about that style layer. Tailwind lies at the core of the ShadUI style layer. However, values for attributes such as color, border radius, etc. are all exposed to the Tailwind config and are placed in a global CSS file as CSS variables. This can be used to manage variable values shared across the design system. If you're using Figma as the design tool, this approach can be used to track the Figma variables that you would have in the design system. Really nice stuff. See a lot of people speculating about TanStack Form. It's largely being made by Corbin, Crutchcorn. He's working really hard on that. Tanner's obviously still involved, but yeah, TanStack Form video coming very soon. I'm waiting for them to give me the thumbs up for it. Anyways, in order to manage the differentiated styling for component variants, CVA, Class Variance Authority, which I pointed out before, is used by ShadUI. Provides a very expressive API surface to configure variant styling for each component. As we've discussed the high-level architecture of ShadUI, we can now dive deep into the implementation details of several components. We'll start this discussion from one of the simplest components in ShadUI. ShadUI badge. I have spent way too much time in my life building, fixing, and arguing about badge components. What do you do when there's an icon in it? Anyways, the implementation of the badge component is relatively simple. Therefore, it's a good starting point to see how the concepts we've discussed previously can be used to build reusable components. We have the CVA and the variant prop type from CVA, import CN, which is the class name helper. Now we specify all the variants of the badge. We have default, secondary, destructive, and outline. These are all the defaults, and you can change these. Like if you want your secondary color to not use BG secondary, you specifically want something else here, or maybe you have a different variant you want to add. This code is in your code base. You can do whatever you want. I also don't love that you've just specified the default variant as default, but fair. As we go down here, you see you export the types, which is extending the HTML div element attributes, as well as adding the custom variant props. Really good stuff. And now we export the function. Super clean. It applies the badge variants, wraps it with the class name helper. So if you apply custom class names, those will override. And then you dump the props, which are all the default div props. Nice and simple. I've implemented a lot of things like this before, but it's good that they have it already implemented for us. The implementation of the component starts with the call to the CVA function. It's used to declare the variants of the component. That's what we just talked about. The first argument of the function defines the base styles. As the second argument, they accept a configuration object that defines all the possible variants. So here we have the pile of default classes on top. And then we have the variants right after that would override those depending on which variant you have selected. It's important to know that what this returns, this badge variants thing, is a function that you then call in code to apply the right class names. One piece I didn't emphasize enough is how cool this variant helper is, where it's using the type definition that you built here by using CVA, and it uses that to properly type the props. So when you have the variant prop for this component and you're not passing one of the variants you've specified, you get a type error, which is really nice. Like you couldn't specify tertiary or bold as a variant because those aren't included here and you'll get a type error. Dope, they included that. Now at the end here, we have our component. Here we can notice we're collating all props other than class name and variant because the other props are random things you might want to do to a div, like an onClick or an ARIA label. Now you can because we're just taking all the default props from divs and dumping them. But we grab the things we specified so that we can apply those properly using the helpers that we have. Makes a ton of sense. I didn't know it used CLSX and then Tailwind merge as 2 layers for the custom class name helper. That makes sense. The benefit here is now when you pass properties, you can give an array or an object that handles all of those things. So technically, if you wanted, you could change the type definition of class name so you could pass it a CLSX merge object that has the different conditions and type errors and things. So you don't have to specify CN or class names or CLSX, whatever you're using, when you call that in the place that you're using this component. But I would still probably just do that there. The function's free. You'll get a type error if you don't make that change. And I haven't seen many examples of somebody passing an object to class name instead of passing a string, but it's worth considering that option. Let's take a look at the link. Links are a super fun example of utter chaos when it shouldn't be. So this utility function is an amalgamation of 2 libraries that help manage utility classes. The first is CLSX. It provides the ability to conditionally apply styles via class name. So here with CLSX, which you could replace it with class names, same thing. One used to be faster than the other. They're basically the same now. We start with text large. So this is the default. This is always applied. But then we have an object, which has the key textblue 500 and the value is active. So if this is truthy, this gets applied. If this is falsy, this doesn't get applied. And it will generate the string of all of the class names that should be applied based on the objects and the strings that you put in here. Very common pattern. If you're using Tailwind, you've probably used one of these at some point in order to handle conditions that are in JavaScript, not in the browser. But how do you combine this once you have 2 different colors being applied, or you have a default color and you're applying a different one? This is not easy to do without a tool like this. And then when you get into those complex issues, it gets harder. Oh, he's actually saying the same thing, I think. Yeah, where CLSX alone cannot achieve our goals. Like here, where we have text gray 800, but then we apply text blue 500 instead. In this situation, text gray 800 has been applied to the element by default. Our goal is to change the text color to blue 500 when the isActive prop becomes true. But due to how CSS cascading affects Tailwind, the color style applied by the text gray 800 will not be modified. I have talked about this so much in videos. Go check out my video about Panda. I think it's the most recent time I've talked about this if you haven't seen it already. CSS cascading order is obnoxious, and the order you put classes in your HTML does not affect the order they're applied in at all. Anyways, this is where Tailwind merge comes in. If you haven't already used it, Tailwind merge applies the last class that affects a property and deletes all the ones before it. So if you have text gray 800, then you have text blue 300, the text gray 800 gets deleted. This is why they wrap the CLSX call with Tailwind merge. Thankfully, they exposed a custom helper that does all of this for you, but this is a pretty compelling example of why you would care about something like this. Now the CLSX output is being parsed by Tailwind merge, and it will handle any instances where something's being overridden and actually apply the override. This approach helps us make sure there won't be any style conflicts in our variant implementations. Since class names props are also passed through the CN util, it makes it really easy to override any style if required. It comes with a trade-off. Utilization of CN opens up the possibility for a component consumer to override the styles in an ad hoc manner. This would delegate some responsibility to code reviews to verify that CN has not been abused. On the other hand, if you do not need to enable this behavior at all, you can modify the component to use CLSX exclusively. I don't think this makes any sense. You shouldn't do this. Just talking about when users are overriding, because you'll still be able to override if you get the order right, but you won't be able to if you get it wrong. I think this is the first point I disagree with in this post. I don't like the idea of removing this behavior by removing Tailwind merge, specifically because sometimes the overrides will work and sometimes they won't. Like if I have text blue 400 applied and I want to override it to text blue 500, that will work because 500 comes after 400 in the CSS. But if I apply 300, it might not work because the CSS file is cascading with 300 before 400. So the class you apply in the component applies before the one that I put in my props. So while I like the idea of not having Tailwind merge behaviors that any dev can override, this lets you override an unknown percentage of them with really, really weird behaviors. So I cannot recommend this simply because it will work half the time and it won't half the time. And that's way worse than it always working. Even if you don't want them to do it, you can't stop them. So you should enable it, not half enable it. I would argue the right way to do this would be to delete the class name prop entirely and just not allow it. Because if class names are allowed, you have to do something with them. And if you're not Tailwind merging them, the behaviors become very unreliable and unintuitive. When we analyze the implementation of the badge component, we can notice some patterns, including some associated principles with solid. It's like they knew Ryan just showed up in chat. So the first point of solid here is the single responsibility principle. The badge component appears to have a single responsibility, which is to render a badge with different styles based on the variant provided. It delegates the management of styles to the badge variants object. Second point is the open and closed principle. The code seems to follow the OC principle by allowing for the addition of new variants without modifying the existing code. New variants can be easily added to the variants object in the badge variants definition. But there's a caveat. Due to how CN is utilized, it is possible for a component consumer to pass new overriding styles using the class name attribute. This could open the component for modification. Therefore, when you're building your own component library with Shadcn, you need to decide whether you should allow this behavior or not. The dependency injection principle. The badge component and its styling are defined separately. The badge component depends on the badge variants object for styling information. This separation allows for flexibility and easier maintenance, adhering to the dependency inversion principle. Interesting. I think that's a fair point. I've never loved putting my styles in an object separate from my markup, but you're winning me over. Point 4 is the consistency and reusability. The code promotes consistency by using the utility function CVA to manage and apply styles based on variants. This consistency can make it easier for developers to understand and use the component. Additionally, the badge component is reusable and can be easily integrated into different parts of an application. There's a couple additional points here that aren't directly called out, like the variant definition is also used to define the types that you use to call this component with. So when you define a variant, it is automatically going to be inherited in the type definition so you can call it on the component. You only have to add it in that one place instead of having to go to 15 different enums in your code base and make sure they all have this new key added to them. Totally haven't had to do that 100 times in my career. Point 5, the separation of concerns. Oh boy. The concern of styling and rendering are separated. The badge variants object handles the styling logic, while the badge component is responsible for rendering and applying the styles. Okay, that's fair. The open-close principle touches on the thing I was complaining about earlier, which is that you shouldn't only apply CLSX and not Tailwind merge on the class names you pass to a Shad component. By only applying CLSX and not Tailwind merge, you're now allowing the developer to kind of override things some of the time, depending on what order they exist in the CSS. That is random, hard to debug, and terrifying. I cannot recommend that. So if you're designing one of these systems on top of something like Shadcn and you want to prevent developers from overriding your styles, the way to do that is preventing them from adding class names at all. Change the type of the component so that you cannot pass different class names to it, and don't dump them in on the actual part at the bottom. But it doesn't really seem like there's a way to partially allow changes. You gotta either add a new variant for the thing they want, or you gotta let them override everything with class names. The in-between here doesn't exist, and I don't love that this hints at the possibility of it when it doesn't exist. After analyzing the implementation of the badge component, we now have a detailed understanding of the general architecture of Shadcn. But this is purely a display level component. So let's take a look at something that's a little more interactive. The switch. Love that he made the real switch in the blog post. Import star as React from React. Import star as switch primitives from Radix UI React switch. Here's the key piece. This is what we mean the whole time we've been saying we're building on top of these headless components. Radix UI has a switch component. Now you get to use it. Let's take a look at this code. Import star as React from React. Import the Shad switch primitive, the CN helper that we talked about before. Const switch. Oh no, forward ref. I'm happy they did this, but again, it's silly to put it this way, but this is the value of Shadcn. Forward ref has done nothing but cause me pain. I mostly know how it works. I'm probably in the top 1-ish% of React engineers in terms of understanding of refs and forward ref, but I still am very scared every time I have to touch it. Ugh. I am thankful someone else did it so I don't have to. React.elementRef, type of switch primitives.root. Oof. Do you know how long it would have taken me to get this code right? Do you know how much longer it would have taken Copilot after getting it wrong 100 times? These types are hard to get. Copilot would never get this right. As someone who's debugged weird ref things because Copilot typed the code wrong, I'm thankful Shad is a better Copilot. They even handled the display name, this is one of those stupid things everyone gets wrong, and it's so nice that they got it right. Now we export switch. Great. A plus. Here we have the switch component, which is commonly found in modern user interfaces to toggle a certain field between two values. Unlike the badge component, which was purely presentational, switch is an interactive component that responds to user input and toggles its state. It also communicates its current state to the user via its visual style. The primary method that users interact with these things are things like clicking and tapping the switch with a pointing device. Even though building a switch component that responds to pointer events is pretty straightforward, the implementation significantly increases in complexity. We need the switch to respond to keyboard interactions and screen readers as well. Some expected behaviors for the switch component can be identified as follows. One would be that it responds to tab key presses by focusing on the switch. Two would be that once you're focused, you can press the enter key to toggle the state. And then three, also very important, is that in the presence of a screen reader, it will announce its current state to the user, because if you can't see it, you can't know what state it's in. So you need that to be handled in a way that the screen reader will parse it. If you've built your own switch, how many of these things did you get right? Be honest, because I know the answer isn't many. The number of times I've seen switches that don't do what they're supposed to, specifically the enter key thing, is obnoxious. Like if I press enter here, toggles on and off, and I can tab navigate through the post and shift tab to go backwards because they're using these things correctly. Very, very, very important. If we analyze the code carefully, we can notice the actual structure of the switch is built up via the usage of the switch primitives.root and the switch primitives.thumb compound components. These components are sourced from the Radix UI headless library and contain all the implementations from the expected behaviors of a switch. You can also notice that the utilization of React.forwardRef to build this component is implemented correctly. This makes it possible for the component to be bound to incoming refs, which is very, very useful when you're trying to track that state to do things like focus state management and integration with external libraries. The example the author gives here is in order to use the component as an input component with the React Hook form library, you need to be able to focus on it with a ref. As we discussed before, Radix UI components don't provide any styling. Therefore, the styles have been applied to the component via the class name prop directly after passing through the CN utility function. We can also create variants for the component if required by using class variants authority. Really good stuff. And now the conclusion. The architecture and anatomy of Shad UI that we've discussed so far is implemented in the same manner as the rest of the components. However, the behavior and implementation of certain components are slightly more complex. Discussion of the architecture of these components deserve their own articles, therefore I won't go into length. Yeah, the calendar one alone would be a very good post and probably a better video. Date time sucks enough that I should have a series about it. He also calls out table and data table, which are very complex and built deeply on top of Tanstack's React table. Form, which is a combination of different things, as well as integrating Zod for the validation layer, which is dope. Shad UI introduced a new paradigm in thinking around front-end development. Instead of relying on third-party packages that abstract the whole component, we could own the implementation of the components and only expose the required elements. Rather than being limited to the opinionated API surface of a pre-built component library when applying your design system, build your own design system with good enough defaults that you can customize later. I will say that Shad UI hasn't invented too much, but similar to how Apple doesn't really invent things, it assembles all of these pieces in what is, without question, the best way to use them together. And I absolutely agree that it represents a monumental, possibly generational shift in how we as developers building good applications think about our component libraries and style systems. Huge shout out to Manupa for this dope blog post. This was really, really good. And 200 followers for a Twitter account by somebody whose video is going to probably get 50 to 100,000 plays is insulting. Make sure you give him a follow if you're on Twitter because he wrote really good stuff here. Thank you guys as always. I'll see you in the next one. Peace, nerds.